So if you're in computer science, you have definitely spent some long nights with Java. I know I have. But here's the thing. Beyond all the coursework and compiler errors, there's this really fascinating story. We're going to peel back the layers on 10 facts about the language that you think you know, but you probably don't.
Oh yeah, we've all been there, right? Staring at the screen, a cold slice of pizza next to you, probably a dozen Stack Overflow tabs open. And then you see it. That dreaded red text, the null pointer exception. It's practically a rite of passage for any coder. But the language causing that headache? It has a much, much cooler story than your data structures textbook lets on.
All right, first up, let's talk about Java's accidental empire. And I say accidental because, honestly, the global powerhouse we know today, it was never even supposed to exist. Now, seriously, Java wasn't built for giant banking systems or massive enterprise backends. It started way back in 1991 as a project called Oak, and its whole purpose was to run, get this, interactive cable TV boxes. But the TV industry just wasn't ready for it. So in 1995, the team made a huge pivot and aimed it at the brand new, explosive World Wide Web. It's just a perfect example of how the most world-changing tech often starts out as something completely different.
You just have to appreciate the sheer audacity of this promise back in the mid-90s. I mean, think about it. Before Java, if you wanted your program to run on Windows and Mac and Linux, you pretty much had to write and compile it 3 separate times. It was a nightmare. Then Java comes along with this just completely revolutionary idea.
So how did they actually pull it off? With this absolute masterpiece of engineering, the Java Virtual Machine, the JVM. The best way to think about it is as a universal translator. You compile your Java code just once into this intermediate language called bytecode. Then the JVM on any machine, doesn't matter if it's Windows, Mac, whatever, translates that bytecode into instructions the local computer can actually understand. It's so simple in concept, but it was completely game-changing in practice. Okay, so we know the origin story. Now let's pop the hood and look at the why behind some of Java's rules. You know, the stuff that can feel a bit annoying at first. Understanding these concepts, though, is what separates a beginner from an expert. And trust me, this stuff comes up in interviews all the time. You've probably complained about how strict Java is, right? It's static typing. But this isn't a flaw. It's a really critical feature. See, Java checks for type errors like this before you even run the program. It won't even compile. A language like Python, on the other hand, is more relaxed. It might not find that type error until the code is live, running in production, which can be a disaster. For really big applications, that safety you get up front is just invaluable. All right, here's a little secret. Java isn't a purely object-oriented language, and that was a deliberate choice. It makes little concession for performance with what are called primitive types, like int and boolean. These aren't objects. They're just simple values stored in a super efficient memory area called the stack, which makes them incredibly fast. Now, when you do need object capabilities, like adding them to a list, you use their wrapper class counterparts. Knowing this distinction is a classic interview question.
We all learn that Java handles memory for you automatically, right? But what they don't always tell you is that there isn't just one garbage collector. There are actually several, and they're each specialized for different jobs. You've got the simple, single-threaded serial GC for small apps, and it goes all the way up to these advanced ones like ZGC, which can manage massive amounts of memory with almost no noticeable pause times.
And that brings us to something you've probably actually experienced. If your Java application has ever just frozen for a split second and then carried on like nothing happened, you've likely just witnessed a GC pause. That's the JVM literally hitting the brakes on everything to clean up unused memory. It really makes an abstract concept feel pretty real, doesn't it? Okay, now we're diving into some of Java's most powerful features. And I mean, these are things that are absolutely essential, but they can also introduce some truly nasty bugs if you don't understand them on a deep level. So in Java, string objects are what we call immutable. Once you create one, it can't ever be changed. This is actually great for things like security and caching, but it means that adding strings together in a loop, like you see on the left, is incredibly inefficient. Every single time that loop runs, you're creating a brand new string object in memory. So the key takeaway is this. For building strings piece by piece, you have to use a string builder. It's designed for this exact purpose, and it's way faster. All right, let's talk about concurrency. This little operation, counter plus plus, looks like one simple atomic thing, right? Wrong. To the computer, it's actually 3 distinct steps. It has to read the value, then add 1 to it, and then write the new value back. Now, the danger is that another thread can jump in between any of those steps and just cause absolute chaos. And that chaos has a name.
It's called a race condition. It's this nasty kind of bug where the final result of your code depends on the totally unpredictable timing of different threads. This is exactly why Java gives you powerful tools like the synchronized keyword and that whole java.util.concurrent package. They're there to help you manage this complexity safely.
So let's talk about Java today. The language often gets a bad rap for being old and really verbose, but that reputation is years and years out of date. I'm telling you, this is not your professor's Java anymore. I mean, just look at how much it's evolved. Java 8 gave us lambdas and streams, which completely changed how we handle collections of data. Java 10 gave us the var keyword for much cleaner, less cluttered code. Java 16 introduced records, which just slashed the amount of boilerplate code you have to write. And most recently, Java 21 gave us virtual threads, which are an absolute game changer for writing concurrent applications. The language is moving fast and constantly getting better. And here's another huge point. The JVM doesn't just run Java. It's a whole platform that supports tons of modern languages. That means the skills you learn mastering how the JVM works are directly transferable to languages like Kotlin, which is the main language for Android development now, or Scala, which is massive in the world of big data.
So if you're ever wondering if learning this stuff really matters, just think about where Java is running right now. It is the invisible backbone of the global economy. It's powering huge banking and financial systems, countless company backends with frameworks like Spring Boot, core big data tech like Kafka and Hadoop, and the very foundation of the Android operating system. It's literally everywhere. Okay, all of this brings us to the bigger picture, and really the most important takeaway from all of this.
Because here's the thing. Learning Java isn't just about passing a course or getting a grade. It's about learning the fundamental principles of good software engineering. The concepts it forces you to master, things like a strong type system, memory management, and safe concurrency, are universal truths in programming. Understanding them deeply doesn't just make you a better Java programmer, it makes you a better programmer, period, in any language.
So I'll leave you with this question to think about. For me, it was seeing a real-life deadlock happen in a project that made all the concurrency theory finally click into place. What was that aha moment for you? Let us know. Thanks for tuning in.